two allies are now aiming for the moon. Putin wants to set up a nuclear power plant with China on the lunar surface.
Russia and China want to install a nuclear plant on the moon.
The head of Russia's Roscosmos space agency has revealed that Russia and China are contemplating a collaborative effort to build a nuclear power station on the moon. Yuri Borisov's report on March 5th outlined their ongoing joint lunar program. This initiative aims to merge Russia's expertise in nuclear space technology with China's lunar exploration efforts to establish a reliable power infrastructure for future lunar settlements. Borisov indicated that they are seriously considering launching the project between 2033 and 2035 to install a power unit on the lunar surface alongside their Chinese counterparts. He argued that solar power alone, even in an atmosphere-free environment, would not suffice for sustaining a successful lunar settlement. Borisov's argument is valid. Solar power does have advantages on the moon. However, due to the 14-day night cycle, the transportation of hefty batteries for energy storage in extreme cold conditions becomes necessary. In addition to discussing a power station, Borisov mentioned a nuclear-powered cargo spaceship. He highlighted Roscosmos' development of a massive vehicle, referred to as a cyclopean structure, capable of various tasks such as material transport between orbits and space debris collection, all powered by a nuclear reactor. While the concept of nuclear power in space isn't new, NASA and its partners have utilized radioisotope thermoelectric generators, RTGs, since 1954. The challenge lies in managing the heat generated. Unlike on Earth, where heat dissipates through the surrounding air, space lacks this medium. Although long deployable radiators could potentially solve this issue, their viability with an active nuclear reactor remains uncertain without testing. Borisov highlighted heat dissipation as the primary technical obstacle before commencing orbital tests and construction. The likelihood of this endeavor's success remains uncertain, especially considering Roscosmos' recent setbacks, including the failed Luna 25 lander mission and strained international relations due to the conflict with Ukraine. However, collaboration with China offers a glimmer of hope. The Chinese Space Agency, CNSA, has demonstrated significant advancements in launch capabilities, evidenced by projects like the Tiangong space station, completed in just 18 months. China's ambition to land a Chinese astronaut on the moon before 2030 underscores their commitment to lunar exploration. Let's explore that project more. The vision. The International Lunar Research Station, ILRS, is the symbol of the Sino-Russian lunar project. It is intended to serve as a center for scientific inquiry, an example of human inventiveness, and a platform for further space exploration. The ILRS project is largely revolved around the power plant, a responsible shade towards delivering the necessary energy to support the ILRS and its multifaceted operations. Through the utilization of nuclear energy as an integral part of the ILRS, the program is empowered to put the long-term scientific missions into effect, to lay the ground for the commercial activities, and to engage into the most challenging and probably the most groundbreaking step in a human history, a human presence on this natural satellite of the Earth, the launch timeline. The cruciality of timing for setting up a nuclear plant on the moon is the same as the technology itself. Thinking about a project that would outline the successive missions and benchmarks set out by Roscosmos and the CNSA sometime around the turn of 2033 to 2035. These operations will entail the surveys, the lander and rover launches, and the significant experiments of the nuclear working in the lunar setting. The implementation of the approach and logic is not just a preparation for an installation, but also a means by which one could learn iteratively and mitigate the risks at every phase. Therefore, each step becomes a success building on the previous one. The timeline testifies to the nature of space exploration, which is exercised progressively and purposefully towards the more significant quests. The importance of nuclear power in space. Utilizing nuclear power for lunar exploration has unparalleled pros. While solar power is not conducive for lunar night and shadowed regions, the nuclear alternative is the best solution because it provides a steady electricity supply both to human settlements and scientific instruments alike. This part focuses on the efficiency, durability, and compactness of nuclear reactors. These space station designs appear attractive, the resource and space limited. Lunar environment require these features. It shows that nuclear technology could be providing bases for longer missions and more. The latter could then support longer medication missions or even travel elsewhere in the solar system. This could lead to a sustainable off-Earth presence. Safety concerns. Safety is undoubtedly a main factor in the use of nuclear technology on the moon. This includes the rigorous designs intended to endure the harshness of lunar conditions, safety measures for there can be no accidents, and procedures for the operator and the rest of the support staff to work remotely. The invention of highly safe reactors is aimed at severe hazard reduction, even despite deviation from the normal state. The final section of the mission plan will focus on the all-embracing diversity of protection approaches from radiation exposure, stabilizing the lunar environment, and maintaining protection of space missions from nuclear hazards, proving the complex interplay between the passion for technological advancement and environmental hazard risks. The future of lunar exploration. The successful operation of a nuclear power plant on the moon will open the way for unthinkable space missions and the permanent habitation of space. It is evident that more steps ahead will be accordingly increasing the momentum in the development of space transportation, Earth-like living structures, and resource processing, possibly creating the moon the ground for planning space missions. The cooperation among countries in such unprecedented undertakings, combined with an international space partnership, would likely open new horizons of international space cooperation, being the pioneers of a unified way of using cosmos. The establishment of a nuclear power plant on the moon is a significant step for China and Russia toward the foot of the moon, since it heralds the arrival of a cooperative interstellar future while also promoting sustainable lunar habitation. Despite these efforts, the joint program faces challenges and uncertainties. It may take several more years to determine if Russia and China will fully commit to cooperation and begin construction. With the timeline extending into the mid-2030s, NASA's lunar exploration plans remain unaffected in the near future. Thanks for watching.